Hello everyone, welcome to my YouTube channel. This is another learning video of Physics IAL, October 2023. So the paper code is WPH1101. Yes, so let's start with the first question without wasting time. So the first question here, okay, so let's read the question first. Yes, okay. So whenever you're reading the question, so you should be very careful while reading the question, because the question, reading the question is very important. All right, yes. So here for question 1 to 10 in section A, select one answer from A to D. So you need to select only one answer out of A and 4 options, okay. So you have to put cross mark on the answer box, which is correct, okay. So let's straight away start with the first question. So here the first question talks about a quantity is either scalar or a vector. Which row of the following table? Okay, so table is correct. So they are asking about a row, not a column. Okay, so this is the row, right? So this is the row 1, row 2, row 3, and row 4. Okay, so we need to find the correct answer out of the 4 options. Okay, let's try to eliminate the options by knowing first. Okay, so if someone is new about a scalar and vector, okay, so let me give you a brief introduction about a scalar and a vector quantity. So scalar quantity is which has only size but no direction. Okay, so size is nothing but it can be anything like length, mass, time, and which can be measured. Okay, but it doesn't have a specific direction. So and then a vector quantity is a physical quantity which has both size and direction. So here the question is talking about, so we have to identify scalar and a vector in a row. Okay, so to make it simple, okay, so energy. So energy is what? Is a work, and we have a momentum, right? And then displacement, time, velocity. First, in the first column, try to identify which are scalar quantities. So displacement. So displacement. Okay, so let's take the block from here. Okay, and then we will try to eliminate things. Yes. So here, if you look at it, okay. So where the displacement comes, let me erase this part. Yeah. Yes. So here you can see there is a displacement is on the vector side. Okay. So yeah, displacement is vector. So displacement is eliminated. So here are the list of vector and the scalar quantities. So you can easily eliminate with the help of this table. All right. Okay. Fine. So the displacement is eliminated, and also if you see velocity, so velocity is also what? A vector quantity, so which is eliminated. So now you can see only the scalar quantity. So what are the scalar quantities here? So energy is a scalar quantity and time is a scalar quantity, right? And then also here on the right side, you can see momentum. So momentum is right here. So momentum is a vector quantity, acceleration is a vector quantity, mass is a scalar quantity, and how about the force? So force is here in the vector side, it's a vector quantity. So we have to identify which row is scalar and a vector. So which is option A. So therefore our answer will be option A. So if you don't remember which are scalar and a vector quantity, here is the list that you can note down in your notebook and just remember these scalar and vector quantities. And also there are some other vector and scalar quantities that you need to know based on size and direction. That's it. Okay, so for this particular question, option A is right. Okay, so let's move on to the next question, number 2. So question number 2 says that which of the following is the SI unit of momentum? So assume you're in an examination, all you don't know the equation for the momentum. In that case, just you can pick out the equation sheet. Okay, so at the equation sheet, so this is the equation sheet, you can see. So what is the formula equation for momentum? So if you look at the equation for momentum, I can highlight it. You can look at that yellow highlighted mark over here. So what is a momentum? Momentum is mass multiplied with velocity. So you can see momentum is what? Mass and mass multiplied with velocity. So for mass, okay, so momentum, the equation for momentum from the equation sheet, okay. From the equation sheet, momentum is nothing but mass multiplied with velocity, right? So here they're asking SI unit. So SI unit is nothing but a standard unit, okay? Yes, standard international unit. So in that case, you just need to know, okay, so how we can measure the mass? Mass is measured in kilograms, and velocity is measured in meter per second. So either you can write kg multiplied with meter per second. So here you can see the right option, which is from the options, the matching is only option A is matching. So therefore we can say again our answer for question B would be A. Okay, so I can erase this, and then only we have to do cross marking. Okay, so this would be our option answer for the question number 2. Okay, so I hope you have understood this question number 2. So let's move on to the question number 3. Okay, so question number 3. So which of the following could be used to describe the elastic limit of a material? So first thing, so we need to know the definition of elastic limit. So what is an definition of elastic limit? So let's see here. You can see, so elastic limit is the maximum stress of a material that can withstand and still return to its original shape when stress is removed, which means, for example, you have a rubber band. So just elongate the rubber band and then leave it. It has to come back to its original position, which is nothing but an elastic limit. So if you assume you're extending the rubber band, and then after sometimes it breaks, so which doesn't comes under elastic limit. So there is a limit for every material behind which it is not an elastic limit. So here also you need to know behind this limit it becomes what? Deformation occurs. So for example, if you have any metal, just you are keep on extending the metal, right? At some point it doesn't, when you leave back, right, it doesn't come to its original position. Okay, so in that case it is nothing but deformation. So also you need to know the more information about this is about a graph. Okay, so let me make the graph a little bit small so that you can able to visualize this better. Yes. So in this particular graph, if you notice, right? Okay, from a particular point, let's say here, right? Point A, if you notice. So what does the point A represents? So up until this is your Hooke's law is accepted, right? And then behind this, it is an elastic limit. So which means they are saying option A, let's read it, the stress above which the material will not obey Hooke's law. So meaning that above here, Hooke's law is what? Whenever it is simple, Hooke's law is just a straight line graph. Okay, so it doesn't even talk about increase in the increase behind the elastic limit. Okay, so therefore we can say, okay, so the stress above which the material will not obey the Hooke's law is straight away eliminated, because Hooke's law is, you can see, until this point. So our question is talking about elastic limit, which is point B. If you look at stress strain curve, this is our elastic limit point, this is proportionality limit. So our option A is eliminated because it represents proportionality limit. It represents proportionality limit, not the elastic limit. All right. So it represents proportionality limit, not the elastic limits. You can directly look at into this diagram. If you once practice this diagram, make a note of it, and then you can see here it is proportionality limit. So here it is elastic limit, and then here it is low yield point, breaking stress, fracture point. So if you remember these 5 points, right? So wherever you see Hooke's law, okay, you can see connect also this point. Okay, so Hooke's law, right? So in that case, we can write proportionality limit option A is represents the proportionality, not the elastic limit. Okay, so option A is eliminated. So next we can see the stress above which the material will be deformed when stress is removed. Yes, so which means elastic limit as per our definition. So what is an elastic limit? It comes back to its original position. So here also the stress above which the material will be deformed when the stress is removed. So which means it will come back to its original position. So which means the option B is the correct option. Okay, so we have to choose our answer for the question number 3 is B. And then C, okay, the stress at which the material undergoes sudden increase in extension. So if there is a sudden increase in extension, it will reach the yield point and then does not come back to the original. So assume you have a rubber band, just extend it, so it will break, right? So it will reach the lower yield point or breaking stress. Basically, if you apply more force or sudden extension, it will break, and then there is a breaking stress. Okay, so the option C is also eliminated. So option D is the stress at which the material breaks. So material breaks is a fracture point, so it cannot be anyway. So the right option for this question will be option B. Okay, so you can select option B is the correct answer for question number 3. Okay, let's move on to the next question, which is question number 4. Yeah. So question number 4 here, the question. Okay, let's first understand and read the question. A ball falls through air. Okay, so a ball falls through air from rest. So which of the following shows the graph of displacement time for the ball, right? So let's analyze this question more in detail with the help of a diagram. Okay, so you can look at this particular diagram. Here, the diagram is talking about completely. So assume you are on top. Okay, so ball falls. Okay, a ball falls through air from rest. So which means this is the case where the ball falls from air. Okay, so if you take this as the axis. Okay, so this is the 0. Here is the positive displacement, and here it will be the negative displacement. So it is confirmed that the displacement is going to be negative. So therefore the option A is straight away eliminated. So because this is the positive displacement, and then also it is constant. You can see here the velocity is what? 0. Velocity is 0. And then here it is negative, but the velocity is what here? Constant. And there is no acceleration. Acceleration is 0. So therefore the option B is also eliminated. Coming to the option C, whenever you are throwing the ball actually accelerates, and also at the same time you can see there is a negative displacement is increasing. So negative displacement is increasing here. Let's say you have -1, -2, -3, and then the time increases, the displacement also increases as you throw the ball from top of the building. You can see on the picture. So option D, C is going to be the correct option. And also let's analyze option D, why it is not, it is also eliminated. Okay. So the reason for option D is eliminated here, it is the displacement is decreasing. Okay, so here the displacement will never decrease as you throw the ball downside, right? So here 1, 2, -3, -4. So it is keep on increasing, right? So in this case, the here is displacement is what? Decreasing. So therefore the option D is also eliminated in this case. So option C is right. Okay, so let's do the next question. So I hope question 4 is very clear, right? Okay. Yes. So next fifth question, question number 5. Here the question number 5 is talking about helicopter. Helicopter moves vertically upward with an increasing speed. So which of the following describes increase in the gravitational potential energy of helicopter? Okay, so let's analyze this question. So here we have to talk about helicopter. So here is the relevant picture for the question. Okay, so assume you have a helicopter, right? So helicopter moves vertically upward. So it is moving upward. So whenever the helicopter is moving upward with an increasing speed. So the speed is increasing. Okay. And then which of the following describes the increase in gravitational potential energy of helicopter? So GPE. So how GPE is related? Work done is equal to gravitational potential energy, because work is also a form of energy. So GPE. So GPE is nothing but mgh. So which means the height must increase also here. All right. So let's analyze each and every option in our question. Yeah. So work done on the helicopter by the force of gravity. So it is not going to be by the force of gravity, which will be against the force of gravity, because the helicopter is moving against the gravity here, right? So gravity is downward. The force is what? The force is not along. Okay, so it is pulling down, right? So the helicopter is against the force, right? So if you have something, right, there is an air resistance, which we call it, right? So there is an helicopter is against the force of gravity. So therefore option A is eliminated. And then the total work done by the helicopter as it moves upwards. So also in the option A, so the gravitational potential energy, right, the GPE will be negative, because the height increases, but so in this case, like what happens, the displacement, displacement increases, force decreases, because it is moving not against the gravity. So it's the option is a very clear that option A is wrong. So total, okay, option B. So the total work done by the helicopter as it moves upward. So we can see what is total work, total work. Okay, so total work is nothing but gravitational potential energy plus kinetic energy. So here we are only talking about gravitational potential energy, not the kinetic energy. So therefore option B is also eliminated. And then option C. Okay. The work done by the helicopter against the force of gravity. Yes. So work has to be done against the gravity, because we are lifting the helicopter, right, in such a way that it is against the force of gravity, right? Already the gravity is downward, and then the helicopter is moving upward. So therefore our option is C is the correct option. Fine. And then next, the work done by the helicopter to increase the speed. No, we cannot say that work done will be to increase the helicopter speed, because definitely here, if you look at kinetic work done, right? So work done is what? Half mv square, and then which is also what? Kinetic energy. So here kinetic energy and speed, so they are talking about kinetic energy, not the gravitational potential energy. So here gravitational potential energy is not relevant to what? Speed. So therefore our option D is going to be eliminated, and also option B is also eliminated, because it includes both kinetic energy as well as the potential energy. But eventually the kinetic energy will be greater in this case when the total work done by the helicopter is moves upward, right? And also look at option A is also eliminated straight away, because it is by the force, so it should be against the force. So whenever an object is thrown up, right, so which is against the gravity, not by the force of gravity. All right, so therefore our options are eliminated. So our clear answer would be for this question would be C. Okay, so our clear option for this question, the answer for this question number 5 is C. Okay, so let's see our next few questions in the next video. Thank you.